Then the why question. The studies of risk factors and how much can they cause the effect. So the cause-effect association, the why, the study of risk factors. For example, risk factor for whether AES would occur or not is whether there is no toilet in the house. If there is no toilet is absent rather than present. So toilet is protective. So you say no toilet means the problem. So you will get exposure yes and disease yes, exposure yes, disease no, exposure no, disease yes, exposure yes, negative, and disease negative. So by these columns, you can study multiple risk factors. For example, you can say whether he used a lift and was exposed to crowd or not in respiratory exposures, and therefore whether the AES was spread by airborne or not. So now how do you analyze these 2 by 2 tables? Let us put these numbers here: 20, 80, 10, 90. So 20 out of 100 is the chance of AES given that you have no toilet. But 20 out of 80 is odds. Now 80, the denominator does not include the 20 numerator in odds, but the numerator includes the denominator includes the numerator in case of risk. So that's the difference between risk and odds. And you have the risk in toilet in exposed, no toilet using river water, and toilets not using river water, and 10 out of 100 here and 20 out of 100 there developed the disease. So the risk ratio is this upon this, 20 upon 100 divided by 10 upon 100, which will give you 2. And the odds ratio is 20 upon 80 divided by 10 upon 90. Use a calculator and you'll get the value of 2.17. So another measure can be risk difference. 20 in the exposed and 10 in the unexposed. So 10 were saved. So in 10 cases, the disease is attributable to toilet being absent. So this is an example of analysis of a 2 by 2 table. And these estimates that you get, the 2 and the 2.17 are point estimates. So they are point estimates, single point. You are using a rifle bullet to estimate the truth, the parameter. It could be 3, it could be 5, but your estimate is that it is 2. Now this is likely to miss, and there is a very high chance of error with point estimates. So you convert these point estimates into interval estimates, lower limit, upper limit, and then the chance of including the truth increase. So these interval estimates, as they become wider and wider, there is a greater and greater chance of knowing the exact truth. So a 95% confidence interval means that there are only 5% chances of missing the truth, missing the real. So how to get this 95% confidence interval of relative risk, or OR? Download this EpiInfo software on your mobiles, which is from CDC Atlanta. We use this software to make the micro mapping of ASJE. You go to open the EpiInfo, go to the StatCalc, choose the 2 by 2 table, feed the numbers 20, 80, 10, 90 here, and you will get these estimates. You remember the 2 and the 2.25? All right. These are point estimates and these are the 95% confidence intervals. So since you see the estimate ranges from 0.98 to 4.05. So if there was no association, if the risks in the exposed and the unexposed were equal, then the no association value was 1. Now since this interval contains that uh, no association value, therefore the conclusion is that there is greater than 5% chance that what I am seeing is by chance, that the relative risk of 2 in toilet negatives is by chance. So it would have been much more reliable if the interval would not have included 1. But of course, it's very, very near 1. So if we increase the sample size, this 0.99 will become more. So sufficient sample size would ensure a significant result. Now supposing we want to deal with multiple causes. For example, we want to deal with toilet type, or we want to deal with exposure to crowds, or we want to deal with economics. So there are multiple risk factors that we are trying to study to determine whether the outcome would occur or not. So here we are, if the effect is numeric, for example, blood pressure or blood pressure response to treatment A or B, then there are other explanations of response. One can be diabetes, other can be age, the third can be body mass index. So there are multiple explanations. So we have data on diabetes, BMI, and so what we do, we take a linear regression, find out the difference of the improvement in the blood pressure, which will be in numbers, and then we put it into linear regression. This is the dependent variable or the determined variable, and these are the determining variables. So there will be some sort of a constant, a baseline risk, if you know nothing of this. But then the treatment type, the diabetes present, absent, or how much, and BMI, you have put in all these factors. So when this beta value associated with x1, if you get an exponential of this beta value, exponential of beta 1, it will be the odds ratio associating treatment type to response in blood pressure, adjusted for all the other explanations of reduction in blood pressure, like presence, absence of diabetes, BMI, obesity, anything else. So all these other explanations are called as confounders. So now, if your outcome is not numeric, it is a yes/no outcome. For example, you have the value that whether AES will occur, did occur, or did not occur. Then the multiple regression model is called as logistic regression. The third is, when will the event occur? Given that if I have cancer, when will I die? Or what is the chance that I survive 5 years? So 5-year survival or median survival. So in that you use the Cox proportionate hazard model. So these are the various types of regression analysis models that you can use when you are trying to determine relationship between cause and effect, etiological factor or disease, prognostic factor or outcome, or treatment type and result. Now, since in etiological factor and prognostic factor, you can only observe whether the cause is present or absent, these studies are called as observational studies. But in the treatment, you are actually administering the cause, and therefore your responsibility increases, because if you are administering the exposure, then these studies are called as experimental studies, and they are usually limited to comparing two treatment types. Now, basically, the allocation to treatment A and B is random, because random ensures that the group A group and B group will be equal on all other explanations of response other than the difference in treatment type. So this random allocation is able to take care of all known and unknown confounders. That means other explanations of results. Therefore, it is the best type of study that you can do. But there's a huge amount of ethics involved if you are planning a randomized control trial, because you have to be sure that the two treatments are, you don't know whether the two treatments are different or not. Because you cannot administer an inferior treatment to any human being. If a treatment is known inferior, you cannot use it in the randomized control trial. Secondly, you must be damn sure that there is no danger in administering the experimental treatment. Thirdly, you must have a documented plan of what will happen in case you detect an unexpected adverse event. And the plan should include stop rules and giving everybody the better treatment thereafter if one of the treatment has unexpected side effects. So this has to be documented upfront. Then you cannot try costly drugs on poor patients, because you found the recommendation on poor patients and are using it for rich. So there is inequity. So sometimes, the treatments are so costly, they are operative. So you can use small RCTs done at many places, and you can combine the results to get more accurate estimates of benefit. And this type of analyzing multiple randomized control trials, combining them if they are similar enough, is called as meta-analysis. So the directionality of the study can be that you can first take a cohort, find out whether the exposure is present or absent, smoking present or absent, or blood pressure raised at 34 weeks of pregnancy or not, and then follow them up to find out whether eclampsia occurred or did not occur in the two groups, and you can analyze them to get relative risk and odds ratio estimates. But these cohort studies are not possible in rare and remote outcomes, because you cannot sort of uh, uh, take 10,000 exposed and 10,000 unexposed to smoking and wait for 10 years to find out how many developed lung cancer. So cohort studies are limited to short-term outcomes and common outcomes, like raised blood pressure in pregnancy. In 9 months, you will get the outcome. Supposing there are multiple outcomes, then other explanations have to be taken care of. These are called as confounders, and in that you use the regression model that we have already explained to you. Example of a confounder is that I had an argument with my senior resident. He said we should operate intercondylar fracture. I said no, treat them conservatively. So I got the statistics. I said that 6 out of 10 patients in the conservative treatment had good results, and 3 out of 10 in the operative group had results. So there's a 2 times in greater chance of good results with conservative treatment. Treat them conservatively. My resident, got another paper and it said that the conservative group were less displaced patients. There were more undisplaced patients in conservative group, and the operated were operated because they were more displaced. So it's the difference in the less and more displacement that explains the good results in the conservative group. So this other explanation of the difference that you are seeing are called as confounders. And the treatment of confounders is regression analysis. We have told you how the beta one will tell you the association, exponential of beta one will tell you the odds ratio between the treatment type and good and bad results, adjusted for all types of confounders. Then in rare and remote outcome, you, instead of taking 10,000 smokers and 10,000 non-smokers and following them up for 10 years to find out whether they had lung cancer or not, you simply take lung cancer positive cases and age and sex matched controls with no lung cancer, and you compare the proportion smoking between the cancers and no cancers. And these are called as case control studies, and basically you get odds ratio association in these studies, and multiple risk factors can be studied in these case control studies. Now I think I have exhausted my information on causality studies, where you relate exposure to outcome.